Okay, so now there are some important expressions or important notes. So for tan inverse 1 plus tan inverse 2 plus tan inverse 3, simplify this one. So okay, tan inverse already we know, tan inverse 1 is pi by 4, and for this expression we will use formula. So first off we have to check whether which formula we have to use here. So this is x and this is y. So what is product of 3 into 2? That is 6. 6 is greater than 1. So if 6 is greater than 1, that means we have to use this formula, that is pi plus tan inverse 1x plus y. Okay, just see here. So I am writing the formula here also, tan inverse x plus tan inverse y. So there are two formulas, right? So first one is tan inverse x plus y divided by 1 minus xy. Here if xy is greater than y, right? No, this formula is for if xy is less than 1, right? If xy is less than 1, already we have discussed in the class. If xy is less than 1, that means this is also positive, this is also positive. So you will get angle in first quadrant, that is 0 to 90 degree. So here if tan inverse, you will get formula as pi plus tan inverse x plus y upon 1 minus xy if xy is greater than 1. So clearly you can see here xy is greater than 1, that means we are going to use this formula. So that is pi plus tan inverse 2 plus 3 divided by 1 minus 2 into 3. So pi by 4 plus pi plus this is tan inverse 5 upon minus 5. So pi by 4 plus pi, tan inverse 5 by 5 is minus 1. So tan inverse minus 1 is minus pi by 4. So this and this will get cancelled, or you will get 1. So like this is very important thing. If anywhere you are getting tan inverse 1 plus tan inverse 2 plus tan inverse 3, keep in mind, okay, memorize this identity. This is equals to pi, right? So next identity, right? Because x and y, these are positive numbers, so we can write down in inverse also. So cot inverse 1 by 1, that is 1 also. So here cot inverse 1 by 2 plus here cot inverse 1 by 3, that is also equals to pi. So this is second one identity. What I am doing, we have studied one formula, that is tan inverse x equals to cot inverse 1 by x if x is greater than 0 for this thing. So here you can see these are positive numbers and greater than 0. That's why we can directly use this manipulation. So this second one is also important. Now if I write down this same thing, see this is 1 only, this is 1. So as you can see, we can also write down cot inverse x equals to cot inverse minus x, suppose minus x equals to pi minus cot inverse x, right? This thing we can also, if we use here, no, if you use this thing, not this thing, so that will be easy. So you have studies that tan inverse x plus cot inverse x, that is equals to pi by 2, right? So cot inverse x you can convert into tan. So here tan inverse or cot inverse x, in place of cot inverse x you can write down pi by 2 minus tan inverse x. So same this identity I am going to use here. So in place of cot inverse x, what we can write down, pi by 2 minus tan inverse 1, right? So let's take it outside now. Yes. So plus this cot inverse half, you can write down pi by 2 minus tan inverse half, plus this, for this you can write down pi by 2 minus cot inverse 1 by 3, that was equals to overall pi. So these two will become pi, so pi, and this is also pi, pi cancelled out. So we are getting here tan inverse 1 minus tan inverse 1 minus tan inverse 1 by 2 this is tan inverse, so minus tan inverse 1 by 3 plus pi by 2 equals to 0. So also we can take these equations towards right side. So this will become tan inverse 1 plus tan inverse 1 by 2 plus tan inverse 1 by 3, that is equals to pi by 2. This also you have to memorize, right? This similarly, if we convert this into cot, because these are also positive numbers, so also we can write down cot inverse 1 plus cot inverse 2 plus cot inverse 3, that is equals to pi by 2. So this also you have to memorize, right?